Hello, welcome to Walk of Breaking It Down. This is the video on the feedback quiz, the second feedback quiz from the exponential functions unit, Unit 5. So this is like a good resource for studying for the test. So make sure you take a good look at this one as well as the first minor quiz to make sure you understand everything before the test comes around. So first one is just graphing and all the features of it. So you're supposed to know how these equations, exponential equations, work and all the transformations that go along with them. I always say make sure that you reflect and stretch, or stretch and reflect before you do any kind of shifting. The number in front is going to be a vertical stretch. If it was negative, it would reflect things over the x-axis because you're changing y values from positive to negative. If you have a negative in front of the x, that's going to reflect it over the y-axis. And this is going to be your horizontal shift and your vertical shift. So what we see here is the 3 is a vertical stretch of 3. I have the graphs down here. So the parent function is there, 2x. And let me run through the idea of the points along with the graph. So you kind of put them together, like we have equation, table, and graph. It's great to kind of have a good image of all of those together. Okay, so we call this the parent function. It's just the base of the rate. It's like the starting place, right? So if I were to graph 2 to the x, that's this blue graph. Sorry, let me put that together. So let's say if x was 0, let's say, and you can see that here on the graph, if x was 0, 2 to the 0 power would be 1, because anything to the 0 is 1. So 2 to the 0 is 1. And you can see that point there I just put. If x was 1, that means 2 to the first power, that would be 2. And you can see on the graph, if I put 1 in, that would show up, that shows up as 2 on the graph. If I put 2 in for x, ooh, that's a big 2, then that's 2 squared, which is 4. So you can see if I put 2 in, that on the graph, it's 4 right there. So there's like 3 points. And the other thing on the outside of this, there isn't any plus or minus at all. So that means your asymptote is going to be right at the x-axis where y is equal to 0. So what we say is y equals 0. That's the asymptote. All right, so that's a good starting spot. Sorry, I forgot to put 4 on the table there. All right, so I got my 3 points on the table, 3 points on my graph. I see the asymptote, and hopefully that matches your thinking of the equation. All right, now we're going to do all this stuff to it. So I have this vertical stretch of 3. What that means is all the y values are going to get multiplied by 3. So this 1 I have here would go to 3, and so I'd have 0, 3 on my graph. Let me try to maybe like put an X on it right there. Okay, if I put a 1 in, this 2 is going to actually go to 6 now, because 2 times 3 is 6. It's a vertical stretch of 3. You could always put that back kind of in the original and then think about, well, before I do anything, I'm going to multiply by 3. So that's what's happening. All right, so then let's put in, take our 4 times 3 is going to be 12. So when I say vertical stretch of 3, I mean multiply all the y values by 3. That's really what's going on. Okay, and then we are going to move things 4 to the left in this case. It's always opposite of what you think. So on a, oh, sorry, I didn't mark those. So 1, 6 would be a point, and then 2, 12 would be a point. It's way up here somewhere, right? So this whole blue graph has kind of been stretched out to go up faster and faster. The asymptote hasn't moved yet. All right, and then when we go plus 4, that means things move left 4. So that means your x values are actually subtracting 4. So this goes to negative 4. This goes to negative 3. And this goes to negative 2. So I'm subtracting 4 from all the x values. On a graph, those 3 points, those 3 x's I drew, are going to go 4 units to the left. So 1, 2, 3, 4. Actually, let me do the next piece before I do the graph. So we're going to go down 5 as well. So that's a shift down. When you go up and down, that's the y values. So 3 minus 5 is negative 2. 6 minus 5 is 1. And 12 minus 5 is 7. So all my y values that have been stretched are now shifting down 5. Okay, so I'm trying to show on a table how these values affect the table values, which in turn is affecting the points, which affects the graph. So those points I used to have, like 0, 3, these x points, right? These 3 x points, they're going to move left 4 and down 5. So let's take this one right here, the one that's on the y-axis. We're going to go left 4, 1, 2, 3, 4, and then we're going to go down 5, 1, 2, 3, 4, 5. So that's that point right there, -4, -2. Hopefully you can see that's right here in the table. I got the -4 was the first point I put in there, and then -2 is where it ends up. Okay, let's do that with the next point, this x over here, 1, 2, 3, 4, and then 1, 2, 3, 4, 5. So that's this red point there, -3, 1. And on the table, you can see that there's -3, here's the 1. And the last one was way up here, but if we go for 4 left, 1, 2, 3, 4, and then 1, 2, 3, 4, 5, that'll end up at this -2, 7. So you see -2, 7 on the table, which should make sense with the equation, the table, and the graph all together. Now, let's talk about the asymptote before we finish. So the -5 is controlling how far up and down you go. In this case, we went down 5. All these y values went down 5. So this asymptote at y equals 0 has moved down to y equals -5. And you can see that that dotted line is there in green. So that's the new asymptote. And the asymptote is an equation, like y equals 0 or y equals -5. Okay, so you need to be able to describe these transformations as well as graph things out. All right, let me erase all this, and then we'll move down to the next problem. A lot of writing, so a lot of erasing. Okay, I think I got it all. All right, again, you can see on there that these are no calculator too. You can always use the baby calculator to do these kind of things, but I don't know if they'll be much help. You should just be able to do them without a calculator in general. But you can always have one if you need it. All right, what's the next one? Similar kind of idea. We have some base parent function, and we're going to transform it. So the negative in front will change your y values, which means things are moving up and down, like positive y's move to negative y's, and negative y's move to positive y's. So on a graph, things are flipping this way, right? So that means you're flipping over the x-axis. Okay, so that's what you have to be able to describe there. And then the +3, that's just shifting up. I don't have any shifting left and right. I don't have any more reflections, but I do have this shift up. So that's a shift up of 3. Now keep in mind, when I do that, the asymptote is going to move that same amount. So you can see on the part B, it says, what's the asymptote? Well, because this moved up 3, that means the asymptote is now up at y equals 3 instead of y equals 0. All right, so we described it. We know where the asymptote is now. And let's take a quick look at this type of equation. What's it look like? So the one we had before was 2 to the x, and it went up like this. Things were double, 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 and things were getting bigger, 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 right? But now things are halving. They're getting smaller and smaller. So no matter where you start, it's whatever you started with is going to go half, 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 half. So even if, like, let's say you started at 100, you'd go down to 50, then 25, and 12 and a half, and 6.25, right? And just half, 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 half. In this case, we're only starting at 1, so we go 1, half, quarter, 1/8, 1/16, etc. So it's going to go down like that and have some kind of shape that decreases, right? So it just helps to have that in your brain. Why does that help? Well, if I ask you for the domain, you'll have a good idea like this. Even though it's curved like this top part doesn't just go up straight up. This will just eventually just keep getting bigger and bigger in the left and the right direction, right? It will go in the left and right direction. It'll go on forever, ever, ever. Even the top part will just keep stretching out left and left and left. All right, it takes a long time to go left, but it'll get there eventually. So the domain is all real numbers. Any x value is okay in this equation. I could put any x I want into there and it wouldn't be a problem. Okay, but we have an asymptote, right? We know that the asymptote used to be 0, and then now the asymptote's at y equals 3. So its after everything's been shifted around and stuff, and it got flipped as well, right? The flipping flipped it to over the x-axis. So it used to be up like this. We flipped it over, and then we shifted it up 3, so it kind of looked like that, right? So that's where my graph is right now. I reflected it, then I shifted it up 3. So left and right, it goes on forever, but the range, the y values, you can see since the asymptote is at 3, it's never going to cross 3. It's going to get really, really close to 3, but it'll never cross it. And then in the other direction, it goes down to negative infinity. So we say y is less than 3. That's the y values. Now you can say these in different forms. The all real numbers could be written with the parentheses and negative infinity to infinity. This is called interval notation. You could do the same thing with inequality notation and have it look like this with the infinities on it. We do not have it equal to. If you put equal to there, that's not correct, because you can't ever reach infinity, so we don't write those. Same thing with this. If you were to put brackets on the end of this, that would be wrong. You have to use parentheses. Okay, so that's one option for all real numbers. I think it's easier just to say all real numbers. You can use the all real number symbol, which is like this. I like that the best, short and easy. Okay, the range, you could add on to this the negative infinity, like it's bigger than negative infinity and less than 3. That's okay. You don't have to have it though. You could use interval notation and say less, or from in negative infinity all the way up to 3 with the parentheses. That's okay. Different way of saying it, right? So it's up to you. All right, last piece. Tim thinks that negative 2/7 is on the point, so they just want you to try negative 2. You take negative 2, put it in for x up here. So you can see I've done that in the equation here. All right, so we have to kind of work through this. This negative is not being squared, right? It's just the 1/2 goes to the negative power. So that means that negative 2 applies to the top and bottom, which means this is going to flip. So that flips, 2 gets squared, becoming 4. So we get 2 squared becoming 4. And that negative that was sitting out there, that's just waiting for you to finish so that you can make it a negative 4. Okay, and then we have the plus 3 is the last thing we would do to get negative 1. You need to be good at this skill, being able to like just come up with a number after plugging something in an exponential equation like that. All right, so practice that if you have trouble. There's some activities that we have that will help you practice that. Just look back in the unit plan. All right, here's some simplifying stuff. The part of these first, oops, I don't know why these are all B, B, B. This should be starting off at, let's restart that numbering. I don't know why it says restart. It should just be A. Oofta. Everything's jumping around now. Okay. Oh, what just happened? I just deleted all my... Oh, I'm in the wrong spot. That's what's going on. Ugh. Oh. Why did that jump around? Weird. Okay. I must have went up a page or something. Okay, here we go. So the number on the denominator when you have a power like that is the root. So in this case, it's a square root. You can see on the next one we have a 3. So that's a cube root. So you take the square root of 36 first. This is another way of writing the same thing. I'll show it as a square root of 36, and then the 3 would be a power afterwards. So the square root of 36 is 6, and then you can do 6 cubed. 6 times 6 times 6, that's 216. Next problem, same thing. I can do the cube root of 8, the cube root of 8 first, and then try to do the negative 4 power after that. The cube root of 8 is 2. 2 times 2 times 2 is 8, right? So that's 2. Then I have a negative 4 power. The negative flips it over, makes it a fraction. And then 2 to the 4th power is 16. 2 times 2 times 2 times 2. So you end up with 1/16. These next ones, I always say do the power of a power stuff first. So this 2 I'm going to take care of first. that distributes into each piece. All three of these pieces, it's not really distributing, but it applies to each piece because this whole thing is being squared. So all those pieces get squared along with it. So this is negative 3 squared. You can see I've reflected that here. So negative 3 squared, x cubed squared is x to the 6th. Y to the negative 5 squared is y to the negative 10. So this negative 2 is going to move up. This y to the negative 10 is going to move down because we want those to be positive, right? So I have y squared on top, positive, and I have y to the 10th on bottom, positive. The other ones all stay where they're at because they're already positive exponents. Now, a big common mistake people make is they think a negative number is a negative exponent and vice versa. That is not true. Be careful with that. All right, so once you have things all positive exponents, then you can simplify. If I have 6x's on the top and 4 on the bottom, 4 of those can cancel off and I'll have 2 left over. The negative 3 squared just becomes 9, a positive 9, because negative 3 times negative 3 makes a positive 9. And then I have 10 y's on the bottom and 2 y's on the top, so 2 of those cancel, and I have 8 left over on the bottom. Just take these one step at a time. Some people try to do too many steps at once. Even me, I just do one step, write it all out, then do another step, write it all out, and then try to finish it off. Okay, this next one, I don't, oh, here's the power of a power. I have a 4 on the bottom. That's a power of a power. So I need to apply that first. So 2 to the 4th is 16. T squared to the 4th is t to the 8th. And then v to the 4th is just v to the 4th. I have this v negative 10. That's going to have to move to the bottom and turn into a positive. And that's why you see those two go together into v to the 14th, 10 plus the 4, because they both end up on bottom. Here I got t to the 5th and t to the 8th. There's more on the bottom than there is on top, so I end up with t cubed on the bottom. The negative stays negative, and some people get confused with the negative. It doesn't matter if the negative is put on top or in front or on the bottom. It's all the same thing. Just put the negative in there somewhere. But 4 into 16 divides in 4 times, so that's 4 on the bottom. Okay, last problem. On part A, we are increasing by doubling everything, right? So we start off with 3 pieces of candy. That's why that's in the front. And our rate is 2. Now I use D for days and C for candy, but you could use any letters you wanted. All right, you need to just be able to logically think out, what's my starting amount? What's my rate? I'm doubling it every time, right? It doubles. And then we have it to a power that matches that rate. So if this is doubling per day, then this exponent should be in days. Okay, same thing on the next one. We have 524 pieces of candy to start with. We're removing, taking out 10%. So that's like, I could take that and put it together and change it into 0.9, right? So removing 10% is the same thing as having 90% left over. So that's why that looks the way it does, 1 minus 10, because you're taking away 10%. And again, that turns into a daily rate of 90% left over each day. So this exponent has to match that. So if it's a daily rate, that's got to be in days. Okay, then we're saying, when are they going to be equal? So you just take whatever you had up here, equal to whatever you have down here, and just set them equal to each other. That's all you have to do. Doesn't matter the order. These can be flip-flopped, right? That's okay. But we just want to find out where they're equal. Then I'm going to use my TI Inspire and figure that out. So let's, actually I have the graph down here, right? I did this on Desmos, but you should be able to do this on your TI Inspire as well, and just graph these things out. You might have to change the window. Let me do it. So we got 520, 524, for those of you who need the help, times, I'm just going to write 0.9 and then raised to the x. So that's one equation. I'm just going to arrow down so that I can look at the next equation. 3 times 2 to the x, right? This is 3 times 2 raised to the x. Please don't change the function notation on the left. Some people do that. And you can see on both of those equations that I hit enter, and it's there. If you want your equation bar to come back up, hit the tab button. I'll get the calculator here. Just hit the tab button. You can see the tab button on the left there. It turned red. That will get the equation bar up. If you hit it again, it'll close the equation bar. It should. On your calculator, it will. On the handheld, I just click on the screen, but you can hit tab and that equation bar will pop up, right? Now I can see one of the graphs, but I can't see the other one. So I need to change my window. So I'm going to go to menu, right? Hit the menu, and this will pop up. Go to your window and go to window settings. Now, in the X direction, it's just going to be in days. So I don't need to go that far. Maybe like -2 up to 10 maybe is fine. In the Y direction, I'm just going to put in -5 so I can see the X axis. And then in the Y direction, I know that one of those equations started off with like 500 pieces of candy. So let me go up to 600 so I can try and see that. Okay. Oh, when you do that, you can see the graph, right? And I can move these around, grab them. All right. I'm just looking for the intersection of those. So I'll go to my menu, analyze graph, intersection. And, it gives you those options. It says, where's the lower bound? So I go a little left, click, and then go a little right, click, and you'll see you get 6.46. So that's where the solution came from, the 6.5 here. That's in days. And then we have 265.1 pieces of candy. Don't get too wrapped up in, oh, you can't have zero point 0.1 of a piece of candy or something. Sure, I could if I bid it. No, I'm just kidding. Um, don't. This is just like a model that's predicting, right? So we don't have to worry about rounding things off or anything like that. Like 6.5 days. Like, okay, don't worry too much. Just say 6.5. Don't round it to 7 or anything like that. Just say 6.5 and 265.1 pieces of candy. Okay, that's totally fine. All right. So I put a little scale in here to kind of guide you in what you would score, but honestly, this is just a rough guide, right? It kind of helps you get in the right ballpark if you're trying to grade something yourself. When we grade your tests and stuff, we look at things holistically and try to make sure you get the grade you deserve for your strands, right? Um, are you just beginning, approaching? Are you proficient at what you're doing, but wasn't exemplary yet? Or is it exemplary, like perfect? Okay. This is a great study guide. Please make sure you know everything on here backwards and forwards.